They're not. Because I couldn't make copies of them. So we're going to do them on our notebook paper instead. Okay. So we're going to write rational exponents at the top. So we're doing the same thing that we've done the other days, but we're going to look at them instead of in the radical form, we're going to look at them as exponents instead. Irrational exponents. Does anyone know what the word rational means when we talk about it in math? Fraction. Fraction. Fraction exponents. Ratio. Yep. Ratio null.
So it's going to be a fraction next time.
Fractional exponents. Okay. So you can see it two ways. They could be written as a to the 1 over n, a to the 1 over n, which is the nth root of a, the nth root of a. So we would say that is the nth root of a. So like a to the 1/2 is the square root of a to the 1/3 is the third root of a to the 1/4 is the fourth root of a to the 1/5 is the fifth root of a. So those are all pretty easy, right? Or we could say a to the m over n, which is the nth root of a raised to the mth power. The nth root of a raised to the mth power. And there's two ways you can write this. You can say the nth root of a raised to the mth power. So you can write it like that. Or you can say the nth root of a raised to the mth power. So you can put the m on the inside of the radical with the a, or you can do the nth root of a first, and then put the m on the outside of the entire thing. Either way, doesn't matter. Okay? So the way that I remember this is I always go back to a to the 1/2 is the square root of a. That's how I always remember this. A to the 1/2 is the square root of a. And that's how I always remember what goes where. Okay? All right, so here are the directions for the examples that we're about to do. The directions are write each expression in radical form. And then we want to simplify the radical if we can. Write each expression in radical form and simplify the radical if you can. All right, number 1. X to the 1/4. How would we write that as a radical? x to the 1/4. Fourth root of x. So anything to the 1/4 power really means that it's a fourth root. I just zoomed in, but did everyone have time to write those instructions? Okay. So x to the 1/4 is really the fourth root of x. Can we simplify that? No, it's just x. It's not x to the 5th, it's not x to the 7th, it's just an x. So that one's done. Okay. Number 2. All right, this one is 15n. So this is a group, this is more than one thing. 15n to the 1/2. So what type of root do we have this time? Square root, okay, square root. And all the stuff that's inside the square root is 15n. Can a 15 be reduced? No, because it's 5 times 3. Okay. Can an n be reduced? Nope. Okay. So we're done. Keep snapping my lid. No reducing for the 15, no reducing for the n. Okay. Okay. 24 to the 1/3. 24 to the 1/3. Root of 24. Can that be reduced? Yes. Okay. Do we want to use the perfect cube method or do we want to use a factor tree? Perfect cube? Okay. What's the perfect cube that's inside 24?
That's not what it means.
So 3 and 8 would be the factor tree. So are we doing a factor tree or are we doing a perfect cube? Factor tree? Okay, so if we do a factor tree, we got 24 is 3 times 8. 8 is 2 times 4. 4 is 2 times 2. So 8 is actually the perfect cube in there. We got a triple of 2's and a leftover 3. Triple of 2's and a leftover 3. So we got 2 cube root 3. Okay, good. All right. Number 4. Seven to the 2/3. 7 to the 2/3. Wait. Cube root 7 squared. Okay. So we got cube root 7 squared or cube root 7 squared. Now, for me to determine which one I'm going to do, I think of which one I can do, okay? So I would do this one if I could take the cube root of 7. I would do this one if I can square 7. So can I take the cube root of 7? No. Can I square 7? Yes. Okay, so I'm not going to do this one. I'm going to do this one. So what is 7 squared? 49. So cube root 49. Okay. All right. Here's the next one. k to the 7 halves. What type of root do we have? Okay, square root k to the 7th, okay, or square root k to the 7th, okay? Now, the square root part is weird, right, because we don't normally put a little 2 there. You guys notice that? I put the squared for the square root, but nobody puts the 2 there, so I'm going to go ahead and erase that because that was funky. Nobody does that. Okay, anyone feel weird about the 7 being on the outside? So most people, like, you could put the 7 out there, but that's kind of weird. So I would probably deal with this one over here, and it can definitely be simplified, right? Because k to the 7th. So what I'm gonna do is I'm gonna write 7 k's. 1, 2, 3, 4, 5, 6, 7. And then what should I do? Circle pairs. 1, 2, 3. Okay. And a leftover. Okay. And so what is my answer? Yeah, k cubed square root k. Perfect. There we go. All right. How do you guys feel about number 5? Good? Okay. All right. Okay. Let's try number 6. All right, number 6 says 3 to the 5 fourths. 3 to the 5 fourths. Fourth root, 3 to the 5th, or fourth root, 3 to the 5th. So I can't do the fourth root of 3 because that's not, I don't know what that is. Okay. I don't want to just do 3 to the 5th though, because I know that this can be reduced, right? A fourth root of 3 to the 5th, right? Because 3 to the 5th is 5 of them, right? That's 5 of them. And if I'm doing a fourth root, then I know I can reduce that. Does that make sense? Okay. So let's think about it this way. 1, 2, 3, 4, 5. What can we do? Circle a quadruple. 1 left over. All right, so what do we have? 3, fourth root, 3. Okay. So even though I could have typed in 3 to the 5th in my calculator to figure out what that number is, I didn't want to do it because I knew that I could reduce a 3 to the 5th. Does that make sense? Okay. All right. Number 7. AB to the 3/4. AB to the 3/4. Fourth root. Okay. AB cubed. Okay, so that's one option. or 4th root AB cubed. That's another option. Okay, I'm going to give you a third option, or 4th root A cubed B cubed. Okay, all of those answers are good. They all mean the same thing. Those are all good. I would accept all of those. Now, Gina Wilson says this is the answer. That's what Gina says. But all 3 of them are right. All 3 of them are mathematically the same. So Gina says this one, but all 3 of them are the same. All 3 of them are good. Okay. Now, it is beneficial to understand that all 3 of them work, because if we were taking a multiple choice test, maybe the Gina Wilson answer is the one that shows up. Does that make sense? Or maybe this is the one that shows up. Or maybe that's the one that shows up. So it is beneficial to recognize all 3 of them, but all 3 of them are good. If we were taking a test and it was one where you got to write the answer in, I would give full credit to all 3 of those answers. All 3 of them are good. Okay? All right, number 8. Negative 6x to the 2/3. Negative 6x to the 2/3. Cube root. And then how should I write the negative 6x squared? Like this? 6x should be in parentheses. Okay. Now, in most cases, people would probably not leave this specifically because of the negative. Most people would simplify this a little bit, because what happens when you square a negative? It becomes positive. So most people would not leave this answer, because they would say, if I have not squared the negative and taken care of it myself, I am leaving the person reading my paper needing to do some math work on their own. Does that make sense? I, as a mathematician, know that when I square a negative, it makes it positive. But if I have not done that work for the person reading my paper, then that means that I am leaving them to do some work on their own, which means I have not simplified the answer. Does that make sense? So I should probably do a little bit more work before I say, yep, that is a simplified answer. So this, even though this answer, this is kind of equivalent to that answer on number 7, this would be a good answer on number 7. It's probably not a good answer on number 8, because I am not doing the work for the person looking at my paper. Does that make sense? And that is specifically because the 6 is negative, and I have not done that simplifying work because I know that a negative squared is a positive. Does that make sense? I'm taking some math and I am not doing it for the person looking at my paper. So let's go ahead and do a little bit more work so that that person looking at our paper doesn't have to. What happens when we take negative 6x and we square it? What do we get? Okay, so 36x squared. That is the better answer for this problem. Even though technically you could say 3rd root negative 6x and then square it, even though technically the best simplified answer here is 36x squared, and if you were to see this as a multiple choice answer, it would almost for sure be the answer with a box around it. It is very unlikely that they would do one of these 2. It is most likely that they would do this one. Okay? Does that make sense? They would want to make sure that you knew to take care of that negative. Okay. All right. Number 9. 7 times 12w to the 1/2. 7 times 12w to the 1/2. Okay. And then, is that it, or should we fix it somehow? The 12 can be reduced. How do we reduce the 12? Okay. So 7 root 4 root 3w. Okay. All right, you guys, we're gonna go backwards. Are you ready? Okay, I think you can do it. I'm feeling pretty good about this. I think this is gonna be. Why are there so many problems always? Gina, why you do this to us?
I know. You just make the problem. Gina gets more money the more papers you make.
Yes. I have always been the type to do like 7 examples. Gina has 34 example problems.
No, we're not doing 34.
I don't think we should do 34. No.
I just had to show you guys what my face looks like.
No, you have no idea. We just went.
Oh, Gina Wilson, man. Okay, the directions for this next set. Hold on, let me zoom back out. The directions for this next set are write each expression.
Yeah, no, that's just 34.
That'll be the surprise, won't it? Write each expression in exponential form. Write each expression in exponential form. All right, have we had time to write the directions? Yes. All right. First problem. Third root of 16. Third root of 16. Now the nice thing about these is you do not have to reduce them. No reducing. That is a reducible radical, but we don't have to reduce it. We don't have to reduce it. We're just going to write it in exponential form. So how do we write that? 16 to the 1/3. All right, next one. Square root x, y. Square root. Square root x, y. X, y to the 1/2. Now, do I just write it like this? X, y, 1/2? Parentheses to show that both of them get the exponent. X, y to the 1/2. All right. Fourth root of 8w. fourth root of 8w. Okay. 8w to the 1/4. Oh, Gina. Third root of 11 squared. Third root of 11 squared. 11 to the 2/3.
No, I wrote it on the wrong line. I just ruined my whole I hate when I do that. Or like I write the wrong sentence from Google and they have to call. Are you crying today? Don't ruin it. I feel like half my paper out of that.
Fourth root of k to the 5th.
I don't feel like, can I see it?
Yeah.
K to the 5 4.
K to the 5/4.
Isn't that nice?
Mm-hmm. Yeah, these are the nice thing is not simplifying, right? Kind of like this.
Wait, it's so pretty.
All right.
I need one more.
15. Square root 3m to the 7th. Now you got to remember what this means. When it has the 7 on the outside, you got to just remember what it means. Yeah, 3m to the 7 halves. 3m to the 7 halves. $16. Fourth root of -2a to the 5th. You're close. -2a. 5/4. There we go. Okay. 17. Square root. 10 to the 5th. A to the 3rd. B. Yep. Okay.
No, wait, 10A to the 3/5. Would it be 5 halves? 5 halves.
Okay, so what should I write?
10 to 5 halves.
Okay, so 10 to the 5 halves, A to the 3 halves, B to the 1 half. Okay, that's one way to write it. Okay, what's the other way? Yep. Uh-huh. Okay, two ways to write it. third root 9x to the 7 y to the 4th. Okay, so this one has two ways to write it again. Okay, what's the other way to write it? Yep.
Oh, me too. Many hypocrite. A big hypocrite. And she wasn't even kidding. I can't stop. Don't play Sophie's stuff. This is the reason why I'm changing to okay, I love it. You were bullying me?
Okay, we got some more examples. Even still, we got a new set of directions. Okay? All right, here's the new set of directions.
Yeah, right.
Can we do one more?
We're going to do number 19, but we got new directions before 19. Okay, so all right, use exponential rules to simplify. Then write your answer as a radical.
Oh my gosh, that's a lie.
I'm going to say that we want. Miss Rice says simplify as a radical if you actually never mind, I'll show you how to simplify. You can keep writing it, that's fine. You can keep writing it in pen. That's fine. You can keep writing it in pen. I'm going to show you guys how to simplify. I'll show you guys how to simplify in exponential form, and that will let you guys kind of pick if you like to simplify in exponential form or you like to simplify in radical form. Okay, I'll show you guys both ways. All right, number 19. All right, I'm going to zoom in. Are you ready? Are we ready? Okay. X to the 1/3 times x to the 4/3. Do you guys remember the exponential rule? Yeah, so I'm going to write this off to the side here in the margin, just to remind you. If you had x squared times x to the 3rd, what would that give you? x to the 5th, and that's because you add the exponents. Okay? That's the rule, add the exponents. So if you have x to the 1/3 times x to the 4/3, what is 1/3 plus 4/3? X to the 5/3. Now, I'm just going to let you guys simplify these using radicals because I think it's easier. We are going to go ahead and we're going to ditch the rules. We're going to do Miss Rice says simplify.
No, I can't write it now.
However you want. Miss Rice says simplify however you want. That's right, Gina Wilson. We have the power to choose. Okay. All right. So I'm going to write down both methods, okay? The exponential method. Are you listening? The exponential method is to separate this fraction where you split it into a whole number and then leave the rest, okay? So the whole number would be 3/3. Does that make sense? Whole number is 3/3. So you would say, okay, I added the two fractions together, now let me split it apart. So the exponential way, I'm going to write this here, the exponential way, and then we'll do the radical way as well. Exponential way would say x to the 3/3 times x to the, if we had 3/3, how many thirds do we have left over if we have to have 5? 2/3, okay? All right. And so that would leave us with just an x right here because 3/3 is just 1. Does that make sense? Okay. And then if we wanted to write this in the radical form, how would we write it? Okay, so that is how you simplify using exponents. Does that make sense? Okay. Now, if we simplify using radicals, we're going to take this answer right here. So that would be the 3rd root of x to the 5th. Does that make sense? 3rd root of x to the 5th. And that's where we would say, okay, 1, 2, 3, 4, 5. And we would circle our triple. And we would say, okay, that leaves 1x in the front. Left over, 3rd root, x squared. Okay? Same answer, 2 different ways of doing it. This is simplifying using exponents. This is simplifying using radicals. The factor tree method. Simplifying using exponents, simplifying using radicals. Okay? All right, let's try the next one. Okay. 20. P to the 1/4 times P to the 3/2. Gino, why you do this to us? P to the 3/2. We need that to be in terms of fourths. 6/4. Okay. So P to the 1/4 times P to the 6/4. What does that give us? P to the 7/4. Okay. Do you guys want to use the exponential method or the radical method or both? We prefer the radical method? You said yes, sir. My feelings are very hurt right now. All right. So how should we How should we write it? Okay? So we got 1, 2, 3, 4, 5, 6, 7. Okay? We got a quadruple. Okay? And so what do we have? Okay? All right, m to the 5 halves divided by m to the 7/4. M to the 5 halves divided by m to the 7/4. So our exponential rule that we're remembering is like x to the 7th divided by x to the 2nd. Anyone know what this is? X to the 7th divided by x to the 2nd? X to the 5th. And how do we get that? Subtract the exponents. So whenever you're doing a division problem, you subtract your exponents. The top and the bottom, you subtract your exponents. So we need to do 5 halves minus 7/4. 5 halves minus 7/4 is going to be hard to do. So what should we do with the 5 halves? 10/4. Okay. So 10/4 minus 7/4 is 3/4. So I'm going to say this is m to the 3/4. Okay. Do you guys want to do exponential simplifying or radical simplifying? Radical? We just feel better about the radical. That feels fair. You are being reasonable right now. I think that's fine. All right, so what should we write? Okay, and we've got m, 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 and what does that tell us? You cannot simplify it. It is already simplified. You are done. It tells you are done. Thank goodness. Okay. Okay. All right. A to the 1/3. A to the 1/3 of the 5 halves. Off to the side, we're going to write x to the 3rd squared. Okay. So this is like saying x to the 3rd times x to the 3rd, which is x to the 6th. And so what's the rule? Yeah, you multiply your exponents. You multiply the exponents. Okay. So a to the 1/3 raised to the 5 halves. How do you do 1/3 times 5 halves? You do not do keep, change, flip. You multiply the numerators, you multiply the denominators. A to the 5/6. 1 times 5. 6. Okay? 1 times 5, 3 times 2, 5, 6. Okay? Sixth root a to the 5th. Okay. 1, 2, 3, 4, 5. There ain't 6 of them, so we're done. Okay, there's a few more exponential rules that we're getting to here. Yeah. All right. 8x squared to the 2/3. 8x squared to the 2/3. Okay. So what do we do with this?
It becomes. How do you just multiply it?
So be careful, because the 8 is actually to the 1 power. Eight to the 2/3, x to the 4/3. Okay. Now, yeah, so this is what I said. This is an interesting one, because this is what I said, where we have 2 different ways we can write it, and this is where it matters. The 2 different ways matter, okay? So for the 8, we can write 3rd root of 8 squared, or we can write 3rd root of 8 squared. So it's not that there's one that's right or wrong. It's that there's one that's easier and one that's less easy. So which one is a little bit easier? I think the second one is. What's the 3rd root of 8? 2. Does that make sense? The 3rd root of 8 is 2. It's easier to make a number smaller and work with it than it is to make it big and work with it. So if we were to make this one big, we would do 8 squared is 64, and we'd be taking the cube root of 64. You can still do the cube root of 64, but we don't know that as readily as we know the cube root of 8. Does that make sense? 64 is still a perfect cube. It's just not as recognizable as the cube root of 8. Does that make sense? Okay. So cube root of 8 is 2. 2 squared is 4. Does that make sense? Both of these are good. One is just a little bit easier to work with. Does that make sense? Okay. So I would work with this one if I was you. I'm going to work with this one. Okay. And then over here we got x to the 4/3. What should I do with that? X to the 4/3. Cube root x to the 4th. So I got 1, 2, 3, 4. Circle 3. 1 left over. Okay. So we said this right here, cube root of 8 is 2. So we got 2 squared, which is 4. So let's put this and this together. What do we have? Good. Okay. Let's do this one. I think we're going to do one. I think we're going to do two more and call it good. I just want to make sure that when you do your homework tonight, there's not any that like catch you off guard. That's what I want to make sure. Okay. 16 to the 2/3 times 16 to the negative 1/3. Wait. Well, it doesn't, so it is a negative exponent. What does it do? It gets positive, right? Because you have 2/3 plus negative 1/3. It gives you 1/3.
The logic wasn't right, but it was the right answer. You were on the right track.
Well, your logic wasn't wrong though, because you're right. When you add them together, it gets the exponent becomes positive.
Yeah, I said when you there's 3 of them, so it gets positive. So
We know what you meant. Okay.
I got there.
So 16 to the 1/3. All right. Now what do we have? Okay. Can we simplify that? Yes. So, okay, so we have cube root of 8 times cube root of 2, right? Cube root of 8 times cube root of 2. Okay, we do have to have a real negative exponent though. What's 100? 100 to the negative 1/2. You're kind of close, but not quite. So what do we do with negative exponents? You turn the whole problem into a fraction. So this is kind of like it's over a positive 1. So how do we rewrite the problem? You take this and you move it to the opposite side of the fraction. So we're going to move it to the bottom, 100, and then what happens to the exponent? It becomes positive. Okay, so it becomes a positive 1/2, and then I'm just going to stick a 1 on the top. Okay, now what's an exponent of 1/2? Square root, okay. And then what's the square root of 100? So negative exponents typically just give you answers that are fractions. So they're not anything to be scared of. They just give answers that are fractions. Yeah. Negative exponents, all you have to do is turn the problem into a fraction and just take them and move them to the opposite side. So if they're on the bottom, move them to the top. If they're on the top, move them to the bottom. And then make it positive. That's all you got to do. Switch the sides. Okay? So we're going to write that down. Everybody write that on your notes. If you have a negative exponent, move to the opposite side of the fraction. And make positive. It was a ghost.
Yeah, it was a ghost. Oh my god. It's so spooky.
So spooky. Okay. I'm sorry these notes took forever. Blame Gina. Do not blame me. Gina. It was Gina's fault. It was not my fault. It was Gina's fault.